Okay, today we are adding and subtracting rational expressions and identifying their excluded values. So, rational expressions are basically fractions where x is in the denominator. So we have these expressions here. Yeah, we have x's in the denominator. How do you add if you have more than one of them? It's a very similar process as adding regular fractions, just numerical fractions. You have to get a common denominator. Okay, now let's take a look at number one and see what this looks like. So the first thing you want to do is factor as much as you can. So the numerator we can't do anything with, and actually we really don't want to, we just want to factor the denominators. We only want to factor denominators here. Okay, so the denominator here, x squared minus 4, that's a difference of squares. And just a reminder, there's a formula there for that. Okay, right, if you have something squared minus something squared, you end up with that. So what's being squared here? Well, it's x. So you're going to have x here and here. And then what's being squared here? Well, that's 2 squared, right? Or in other words, the square root of 4 is 2. So that's what's going to go here and here. So minus 2 plus 2. Okay. The second fraction, there's nothing to factor. Okay, so we have that. We want to, before we proceed, identify any excluded values. Basically, what are the values of x that would make either of the denominators equal to 0? Well, it would be positive 2, right, because 2 minus 2 would be 0. Negative 2, negative 2 plus 2 would be 0. And then we already have positive 2 from this one, so we don't need to say it twice. So we have 2 and negative 2. If you wanted to write plus or minus 2, that's fine also. All right, so we have this. And now we need to get a common denominator. So what you do to identify that? Well, this denominator is made up of x minus the factors x minus 2 and x plus 2. This one just has the factor x minus 2. So we have to make these look the same somehow. Well, I notice that they have the x minus 2 in common. That's nice. But this one's missing, this denominator is missing the x plus 2. Is there a way I could make that show up there without actually changing the value of the fraction? Well, yes, there is. I'm actually going to move this out of my way. I wrote that a little close because I'm going to need some room there. Let me just write that up here. Yeah, what we could do is we could do this. We could put it in parentheses if we want, it doesn't matter. So I'm multiplying this second fraction by x plus 2 over x plus 2. Now notice this just would cancel out to 1. You don't want to actually cancel it out, but if it were, cancel out to be 1. So we're really not changing the value of the fraction, right? If you multiply something by 1, it doesn't change its value. But now what we'll get as a result here, let me multiply these out. Just a quick review of multiplying fractions, you just multiply straight across, right? So 1 times x plus 2 is just going to be x plus 2. I don't really need the parentheses. Down here, I do need to show the parentheses. I need to show multiplication between these two factors. So I have x minus 2 times x plus 2. Let me bring down that first fraction. It's going to be the same thing. Haven't changed that at all. And now notice we have a common denominator, okay? So now we can add these up. We can put them over a single denominator on the next step, which is just going to be that denominator, x minus 2 times x plus 2. And then adding these up, well, there are no like terms. So we just have this, okay? So that's what we will end up with. Now, what you want to check at this point is if this is factorable, because it's possible you could cancel out some things. But there are no two numbers that would add to 2 and then, I'm sorry, multiply to 2 and add to 1. Okay, so that's actually not factorable. We're done here. Now, now we want to go ahead and write the excluded values here along with our answer as well. So there we go. That's what that ends up looking like. Okay. Let's take a look at another one. So let's just do number 2 here. So again, we just want to factor those denominators. So we'll have 1 over, and this is going to be, let's see, two numbers that multiply to -4, add to 3. Okay, so this is a trinomial this time. We didn't have this in the last problem. So yeah, we're looking for two numbers that multiply to this, add to this. Well, that would be +4 and -1. All right, 4 times -1 is -4. 4 plus -1 is 3. Okay, and then we do something similar in this other fraction. We have to find two numbers that multiply to 2 and add to -3. Well, that's going to be -2 and -1. So we end up with this. Okay, now I need a common denominator. This one's a little different than the last one. I see that, first I'm going to see what do I have in common already. Well, I have these in common already. You might want to just underline those so we don't have to worry about that. But this one has an x plus 4 in it, and this one has an x minus 2 in it, and we need these two denominators to look the same. So let's focus on the first denominator first. What is it missing compared to that? Like, what is it missing from this one? Well, it's missing the x minus 2. So I'm going to have that present in my denominator here. And of course, in order to sort of follow the rules of algebra here, you have to multiply by x minus 2 over x minus 2 so that you're just multiplying by 1. Over here, what is this one missing comparing it to this? Well, it's missing the x plus 4, so you're going to have to multiply this fraction by x plus 4 over x plus 4. One thing I forgot to do here was identify excluded values. We should do that now. So I can just look at the original 4 here. I don't have to worry about those. Well, they're here anyway. So we have -4, 1, +2, and then we already have 1 from that one. Okay, so those are our excluded values. Okay, back to this. We are going to multiply these, so we'll end up with x minus 2 up top, right? 1 times x minus 2 is just x minus 2. These, you just put them all together. You don't need to FOIL these out. Okay, just leave it like that. And then same deal over here. You're going to have x plus 4. And then you can just put these all together. It doesn't really matter to the order. Hey, if you're picky about that kind of thing, you can put them in the same order as this one. Okay, I'm probably going to do that. But you don't have to. It's nice, though, to do that just to make sure, oh yeah, they are exactly the same, right? Okay, so we have this. Now we can actually subtract the fractions because we have a common denominator. So in the next step, I'm going to have everything over a single denominator, which is this. Now careful with subtraction. Here's what it'll look like. Notice I put those parentheses in. This minus applies to that whole numerator. It's very easy to, if you didn't put those parentheses there, you would have the wrong answer because this should become a -4 right after I distribute that in. So just be really careful there. That is another very common error on these problems. So yeah, I'm going to distribute the minus, or if you think of it as distributing a -1, it doesn't matter. So we'll get x minus 2 minus 1x, or just minus x, and then we'll have -4. I guess I'll rewrite the whole thing out again since we're doing notes here. Now, if I was doing this myself, I might just, off to the side, sort of simplify this and then write my final answer, okay? Okay, so we have that, and these cancel out, right, because x minus x, that's 0, and then we have -2 minus 4 being -6. So we'll end up with -6 over all this business here. X minus 2 times x plus 4 times x minus 1. And we have to write down those excluded values that we identified earlier. So x cannot equal -4, 1, or 2. There we go. Okay. All right, let's do number 3 together also. This one's a little bit different. So again, you want to factor those denominators. So let's see, this is a trinomial, so we're looking for two numbers that multiply to 2, add to 3. Well, that'd be x plus, or it'd be 2 and 1. So we get x plus 2 times x plus 1. And then over here in this denominator, well, I notice both of those terms have an x in common, so we can sort of take out an x. X times x would give us the x squared. X times 1 would give us the x. So there we go. They're factored or excluded values. X cannot equal -2 or -1 or 0, right? Because of this x out in front here. And then we already have, this would be -1 also. We don't need to write it down again. So those are excluded values. Now we think about what we need to multiply each. Oh, and I did not write those in a great place, did I? Let me move that up a little bit. So yeah, we'll need to find what's missing in one or both of the denominators in order to get a common denominator. So looking at this first denominator, well, it has the x plus 1, like this one does. Okay, that's what they have in common, but this does not have an x. So we're going to have to multiply this fraction by x over x. And then let's see, this one is missing the x plus 2. So we need to multiply that by x plus 2 over x plus 2. And let's see what we end up with here. We'll get x times x in the numerator, so x squared. And then our common denominator here is going to be, those put together, x times x plus 2 times x plus 1. And then the numerator here, just for right now, you could write it like this. We'll have to distribute that soon. And then the common denominator, I'm going to go ahead and write it in the same order as this one. It doesn't really matter, though. I just like them to look the same, exactly the same. All right, so there's that. And now I'm going to go ahead and probably do 2 steps at once here, if we're comfortable with that. I'm going to go ahead and distribute this, but then also put my result plus this over the common denominator here. So here's my common denominator. And then I'll have that x squared. And then x squared times x, well, that's x to the third. And then x squared times 2, that's 2x squared. Okay, and now I notice I have some like terms here. So I'll have 3x squared. And actually, I'm going to go ahead and put that x to the third first. It's always nice to have things in standard form, meaning you have the highest exponents first. So I'll have x to the third first, and then I'll put my 3x squared next. And that's all over x times x plus 2 times x plus 1. Let's go ahead and factor this numerator. You want to do that just in case something cancels out. So I'm going to take out an x squared, numerator here, and then x squared times x would be x to the third, and then x squared times 3 would be 3x squared. And then I have this. And something actually does cancel this time. I have x squared and I have x. These are both involved in multiplication, right? And so I can cancel out an x. So what that basically does is that, right? Because I'll just have, it might have been a while since you've had this situation, but we have x to the first here, x to the second here. In a way, you subtract the exponents, or here's another way to think about it, you guys, if you're a little rusty on this, x squared is like this, right? X times x. And so one of those cancels out, and you're just left with an x on top, okay? So what this comes out to then is, just rewriting it here, x times x plus 3 over x plus 2 times x plus 1. And then writing our excluded values, which I identified up there, are -2, -1, and 0. You do need to include the 0, even though that x canceled out. This problem has a history, and at some point there was an x in the denominator. And so you do have to state that in the answer. Okay, you guys go ahead and do number 4. All right, so here's what I got. A couple of interesting things on this one. This minus out here, just be really careful. A lot of sign errors can happen. I was thinking about doing 2 steps in one and distributing at the same time. The danger with that is it's really easy just to consider this a positive 5. I mean, you could do it that way and then distribute the negative again, but I opted just to rewrite it like this. That way, I just thought of it as distributing negative 5. So I know I did that on the last problem. I did 2 steps in one. You might want to avoid that just because if you take that shortcut, you might run into that error, just some sign errors. Okay, so then I ended up with this. I went ahead and distributed that, the negative 5, like I said. I did check to see if I could factor this. This is a fourth, and this is a 1. You can't factor, something like that. So this is as far as we can go. And I did forget to identify those excluded values when I should have, but it's not a big deal. Make sure, though, you go back here to identify the excluded values. It wouldn't really matter on this problem because nothing got canceled. But if something did get canceled, that's why we identify excluded values back here before anything gets canceled. Okay? All right.